Hello, my name is Dr. Vlad Krotov, and in this video lecture I will try to answer the following overreaching question. Why R? Why are we using R language and R studio environment for developing analytics applications for this course? This video lecture will also serve as a conceptual introduction into the topics of data science, research, and other topics that are related to this course. So why R? R language is becoming one of the main languages of data science. Now, data science, the job of a data scientist has been labeled as the sexiest job of the 21st century. What's happening nowadays is that in a lot of industries, organizations are realizing that customer data competing on analytics is the way to go when it comes to gaining and sustaining competitive advantage. And this is happening in many industries, even those industries that are traditionally labeled as low tech, such as agriculture. Nowadays, agriculture is also very much driven by data related to crops, soil characteristic, weather, and things like that. And all this data is gathered, analyzed to give farmers, to give food production companies a competitive edge. So that's why the job of a data scientist, meaning somebody who's in charge of data analysis and data presentation that influences decision making, is becoming the sexiest job of the 21st century. Back in 2018, there was a prediction made by McKinsey company, a leading management consulting company, that United States alone would soon face a shortage to the tune of 200,000 people with deep analytical skills. So this is one answer as to why we're using R. R is one of the main languages of data science. I would say the other one is Python. I regularly check surveys of tools, most popular tools in the field of data science, and R and Python, they always come up as the top two tools used by data scientists across all industries and academic fields and all possible areas where data analysis is used. They kind of go hand in hand. I would say that at this point, I think that this is the difference between R and Python. Python also has quite extensive collection of data analysis tools. One of the advantage of Python is that it has a lot of web frameworks, so it can be easily integrated with websites and with consumer products. Digital products can be easily built with the help of those web frameworks if you're using Python. Now, the collection of analysis tools that R has is simply unmatched. We're going to talk more about it, about packages or user-developed extensions of R language, and Python simply cannot match that, at least not at this point of time. So R was specifically written for data analysis. You can develop very sophisticated applications, but those applications are more on the analytical and research side rather than consumer side. Although R does have libraries such as Shiny, it's an add-on for building web-based dashboards or web-based applications on the top of R code without actual knowledge of HTML, CSS, or JavaScript. So all in all, I would say that Python seems to be more geared towards the practitioner community, while R language as a data science tool seems to be more accepted within the field of the community of academic researchers. And also, serious hardcore researchers using statistics in their field, something related to medicine, investment banking, economics, and things like that. Now, I already mentioned data science several times, and I also said that a lot of experts believe that data science will continue being a very lucrative and growing field, at least for the next few years or maybe a few decades. But I've heard a lot of people saying that, well, I don't want to be a data scientist because I hate stats. And I understand that sentiment. I mean, stats looks like a very dry subject. I know that a lot of business school students, when they take stats, they probably hate it even more than accounting. And accounting is also believed to be a very dry, kind of factual, numbers-oriented subject. What I realized myself is that, first of all, it takes a special person to do stats, to like stats. I mean, you really need to have that kind of way of thinking about the world. And then also, like, the way statisticians think about the world is different. It's even different from the way mathematicians think about the world. What I've noticed about myself as an undergraduate student and then as a graduate doctoral student, I took a lot of courses in stats. And I think I got A's in most of those courses. I think there was only one course where I got a B, one course related to statistics where I got a B. But it's only after I graduated and started doing research myself, it's only at that time I started to develop an understanding of what statistics is and how statisticians think about the world. So this certain degree of resentment or caution in relation to stats is completely understood by me. But I would like to emphasize that data science is not just about stats. It's not just about statistics. Of course, to be a data scientist, you need to know something about descriptive statistics such as mean, median, mode, inferential statistics like regression, ANOVA, clustering. And also nowadays, a lot of techniques are driven by machine learning, artificial intelligence, and all of those tools are implemented in R. By the way, I've noticed that a lot of times industry data scientists or industry analysts, they don't really go beyond that descriptive statistics part, which is using mean, median, mode to describe trends or best practices within a specific industry. So even if you master that, and I think at this stage of your academic career, you already understand those ideas. You already have enough what it takes to be a data scientist or data analyst in certain jobs in certain organizations. But again, data science is not just about stats. You also need to know something about the domain within which you are doing research. In other words, you cannot be a data scientist in general. I mean, you need to understand the context within which the data is produced, and also you need to understand the context to make conclusions, valid conclusions that are derived from the data. So, for example, you may be a data scientist specializing in marketing or online marketing, accounting, economics, finance, education. Maybe something related to the field of public services, social media, medicine. There are also computational linguists, like they're using computational tools to understand English literature and things like that. So you need to know something about domain. And of course, you need to know something about IT, right? A lot of times nowadays, well, not a lot, I would say almost always, data science projects and analytical tools, they're implemented with the help of information technology. So knowing programming, especially programming in languages that are geared towards data science, such as R, Python, sometimes Java and C++. For example, a lot of R packages are actually written in C++ to increase computational speed. Also understanding something about databases, because oftentimes data is managed, data used in data science project is managed using databases. So knowledge of database management systems will come in handy. Also, if you're getting data from the web, then you need to know something about most common standards or markup languages used on the web, such as HTML, CSS, XML, JSON. And then if you're dealing with big data, you need to have an understanding of such architectures, platforms, or tools as SAS, Hadoop, Spark, and things like that. Most importantly, underneath all of those areas of knowledge is curiosity. I mean, you cannot be a data science unless you're curious about answering, unless you're curious to find out answers to certain important questions, and you're willing to torture your data back and forth with all kinds of statistical techniques and tools until you get the answer that you're curious about, that you're passionate about. So what I'm trying to say is that don't rule out a career in data science simply because you did not enjoy stats as an undergraduate student. Data science is not just about stats. And the good thing about data science is that you do not have to be a brilliant statistician or brilliant web developer or brilliant database developer. As long as you know enough in all those three areas to run, as long as you know how to run certain statistical tests, you understand how technologies work, you understand something about the domain, although again, you don't have to be a domain expert, you should be able to answer the questions that you formulate. Again, it's all driven by curiosity. If you're really curious about answering a particular question, you'll find out more about the needed statistical test, about the domain, and about the IT tools that you need to address that particular research question. And also, if you're specializing in information system, like, let's say you're an undergraduate CIS computer information student or graduate MSIS student, then you already have exposure to a lot of those knowledge areas. I mean, typically, in a graduate or undergraduate program in information system, there are courses related to business, there are courses related to technology, something related to programming, networking, security, and also there are courses related to data management, database administration, and things like that. And then what many computer information systems undergraduate and Master of Science in Information System graduate programs equip students with is soft skills related to leadership, teamwork, communication, and personal integrity. As a data scientist, you will have access to sensitive data that needs to be protected, that needs to be properly stored and handled. So this is where personal integrity comes into play. A lot of research related to data science projects shows that communication skills are crucial, because not only you need to be able to analyze data and derive valid conclusions, you also need to be able to influence decision making within your organization by having great communication skills. And also, data science projects, at the end of the day, they're projects, just like IT projects or construction projects. So being able to understand how to manage teams, how to lead people will also come in handy. So what I'm trying to say here is that as an MSIS major or as a CS major, you should have all the foundational knowledge that you need to be successful in data science. So what are the things about R that makes this language, this environment, especially suitable for a data scientist? In a way, R is a programming language, just like many other programming languages. And however, this is a programming language developed specifically for data manipulation, statistical analysis, and data visualization. Most general purpose programming languages, they were developed for various purposes other than data manipulation, statistical analysis, and data visualization. So for example, you will see that there are a lot of built-in features of R in relation to data analysis, unlike for other languages that would require like a specialized library or something like that. So just like any programming language, R includes variables, loops, conditional statements, recursive functions, input-output commands. I would also add here is that although R is usually used in procedural fashion, where data analysis script is developed, where like one line is executed at a time, R is a full-blown object-oriented language, similar to the likes of C++ and Java. So what are some of the unique data science features of R? Well, first of all, you have numerous functions for data retrieval, manipulation, and storage. Those functions are available together with R language base and also in the form of various libraries or packages, as they say in the R community, developed by the user community. There are also built-in operators for calculating using arrays and matrices, something that is used heavily in multivariate statistics. Tools, all kinds of tools for basic and intermediate statistical analysis, anything starting with generating descriptive statistics and then all the way up to regression, structural equation modeling, data mining, machine learning, and so forth. I like to paraphrase that old MasterCard commercial that went something like, there are some things that money cannot buy. For everything else, there's MasterCard. I guess I can say the same thing for R. There are some data analysis techniques that computers cannot do. For everything else, there is an R language. Although it's hard for me to think of any well-accepted statistical analysis technique, be it in relation to quantitative data or some kind of analysis technique in relation to qualitative data or text, that is not yet implemented in R. Also, R has very extensive graphics packages for data analysis and visualization. They are much more extensive than what you can see in Excel, because you can build any visualization, you can automate those visualizations. So it may look at first a bit complicated, but you will see that the visualizations in R are much more complex than what you'll get in Excel. There are entire books and volumes written about for example, one single data visualization package in R, which is ggplot2. R can be used in conjunction with C, C++, and Fortran for improving computational speed. For example, a lot of data wrangling packages in R are actually written in C++ to speed up computations. By the way, R can also interface with code written in Python, which is another popular language for data science, and that increases usefulness and interoperability of R as a data science platform. Now, the most important, in my opinion, and the most valuable feature of R is that there are those user-contributed packages available from the Comprehensive R Archive Network, or CRAN. To be honest, by the time you watch this video, this number will be outdated. It was 5,000, 6,000, 12,000. Now I think it's 17,000 at the time I'm recording this video. I don't want to update this number all the time. But there are thousands and thousands of user-contributed packages available from CRAN. Again, if you can think of any data analysis, most likely there is a package for it. I explore you to pause this video and go to the CRAN repository and just browse through the packages to see how many packages are out there and whether there's something that interests you something that can be used for your own research purposes. Those are just some examples of R packages. This was my package that was published a while ago called Dice Crawler. It was a web crawler designed for retrieving data for dice.com. Now, unfortunately, dice.com discontinued supporting their public API, so I had to discontinue my package as well. Then there is Plier, dplyr packages for various data manipulations written by Hadley Wickham, who is one of the most well-known contributors to the R language. Then you have this TM package for text mining. Then you have all kinds of packages for machine learning. ggplot2 is by far the most popular and the most extensive tool for data visualization in R. And then you have Sujet package that I use for things like sentiment analysis or plot arc analysis. It's actually used by English professors and scientists who do research in relation to English literature to analyze plots of literary works. And also it has some tools for sentiment analysis to understand emotions embedded in text, and that's what I personally use this package for. So again, our package has this huge Wikipedia of data analysis techniques written by users, available for free. And I think other tools find it hard to compete with that. Just like Encyclopedia Britannica can hardly compete with Wikipedia, I believe that R has a very bright future, because it's hard for me to imagine a tool, especially a proprietary tool, that can compete with that kind of community that develops thousands and thousands of packages every year to implement any kind of analysis techniques possible. So let's just jump right in. Let's get started with R language and R environment. To get started, you need to download the so-called R base. So this is the R language itself. So go to this website, find the appropriate installation file that will depend on your operating system. So install and download R. Once you install and download R, you can start using R language from command prompt. I have some notes following on that, how it can be done. But most people, they download and install an integrated development environment IDE called RStudio. So RStudio will be installed on the top of that R language base, and it has all kinds of useful functionalities for writing, debugging, manipulating code in R, and also managing data science projects in R. So go to rstudio.com and install that free desktop version. Both of those tools are free. They are open source. At least some of those tools are open source, so you should go ahead and install it. And then later on, you will learn more about using those tools and about the interface of R and RStudio. So that completes my presentation on R language. So hopefully I was able to answer the question like why R, why R is used in data science. And also this video lecture provided a conceptual introduction into data science, which is the main subject matter of this course. So thank you for listening.